In today's video, I will teach you what is inside our reverse engine of APC inverter, so which I opened a previous video. Today, in this video, I will teach a circuit diagram. But problem is that the circuit diagram is not fully complete. There are some assembly components, so I made a 50% circuit or 50% circuit is not possible to make. And now it's time to see reverse engineering, and I'll explain how it works. Live goes in and those switch, then those setting output, and there's the MOV for overturn protection, and then those to the capacitor 0.4 microfarad for 50 volt to smooth, and then line filter coil for removing noise, then those 0.22 microfarad capacitor 250 volt and re-smooth. Now the last wire capacitor is in series to filter further filtering, and these two capacitor needs ground equal to the earth terminal or grounding terminal, and then those fuse for safety 2 amp fuse, then those other line filter coil for filter coil to the again filtering EMI filtration, and then those rectifier made of PT64 4H diodes, then those 10 microfarad to 450 volt capacitor to smooth DC smooths positive to capacitor positive, negative to negative of the capacitor to the rectifier, and positive that directly to the primary terminal of the this transform SMPS transformer, and negative goes to the take to 60 MOSFET source terminal with, and drain terminal is connected to the other terminal of the primary coil, and this transistor can switch the transformer primary with on and off in according to make a step in switching the voltage, and there is a 161 kilo K capacitors and 102 capacitor with 1 kilo ohm resistor in order to make a stubborn network for preventing extra spikes made of this transformer primary winding and transformer auxiliary winding, those HF2M diode for filtering, and then smooth by 2.2 microfarad 50 volt, and then those ICP number 2 and ICP number 3 IC UC38 438. ICP number 3 is connected to the 4.7 microohm to drive the MOSFET, 4 is ground and 7 is also ground, 5 6 are connected unknown value capacitor to a ground. These two capacitors are SMD, and pin number 1 is a feedback input, which is pin number 4.7 kilo ohm resistor to limit the current, and then is the upper collector terminal, upper emitter is connected to a ground to give a feedback. Once the transformer switching, the MOSFET made a switching, the transformer generates a voltage which is 16 volts, then rectifier HS2 diode and filter 16 volt for 7 microfarad capacitor, and then made a voltage divider, which voltage divider made of 68 kilo ohm is to pull up and pull down by 91 ohm. The feedback of this TL4331 variable general diode just a certain voltage which can drive this output LED for feedback, and there is a 30 ohm resistor to limit the current for this LED optocopter, and ground also goes to the MOVs. 2 MOVs parallel to the one side of the fetch line, and 3 PTC in the other side to the ground to the modem coil to in order to cancel the noise in the modem and other sensitive appliances. Live terminal with 220 k 4 resisting series, meaning 800 kilo ohm resistor in a total overall 8 kilo ohm resistor, and then goes to a feedback terminal, and other neutral terminal is also connected to the other 200 kilo ohm 4 resistors, meaning 800 kilo ohm resistor to the feedback circuitry, which is sense when input is available or not. If some case inverter input is available, it can turn on this relay, which can turn the output directly to the input line, meaning when you plug in inverter into the power source, the main processor knows taking a feedback by these two terminals knows power is present, and it can switch directly this relay on, and your load is automatically shifted to the main power grid line, not to the inverter line. And this pin number 1 and this opto collector with 2.2 ohm resistor with 8 ohm resistor, and there are diode cross negative line where other snubble network made of 3.3 kilo ohm resistor and 2 11K summit capacitor in parallel, and then those to a positive line of this 10 modified 450 volt capacitor, as well as this transformer primary terminal. Is the final output which draws the battery with help of series fuse to charge the battery. Now those are inverter circuitry. Let's flip the paper. This circuit is not fully complete because there are a couple of assemblies things, and there positive goes to a drain of a MOSFET IERL 31713. There are used an HB configuration, so both the drain are connected to a fuse to a positive, other two MOSFET source are connected to a ground, and these MOSFET source or these MOSFET drain are joined together, and these two is connected one coil. Another coil connected to other MOSFET drain terminal, and both the MOSFET first terminal also connected to a ground. So when these both MOSFET there is discharged 39 dead ohm resistor in order to set up the MOSFET automatically. So when microcontroller processors drive the MOSFET alternator will drive. It made a magnetic field both way, voltage flow left flow one way to other way and other way to first way. That produce upward magnetic field, which is generate AC voltage with those pure sine wave to output. And then this is also other winding, auxiliary winding, which is also designed by these two MOSFETs in order to make output. Oops. I remove extra papers, it will wobbly, and once its output is generated, output goes into this switch jack, and one terminal is go to output directly, and other terminal is switched by relay. So if your temperature is 120, then this main processor also knows is a 120, it's considered as a 120 volt or 240 volt. It can switch the relay accordingly, which then output the voltage other terminal between these three terminals to go there, and then goes to out this transformer, and this transformer as well as this transformer as well as this transformer as well as these capacitors by these capacitors, and then its transformer is also connected parallel with these output. So this output is also used to transform this step. This is a step up transformer, and there is a step down, again step down, and this step down is due to microcontroller for check the waveform of the output is pure or not pure, and phase is directly, neutral is goes to the also directly, and neutral to phase there to one capacitor for smoothing, and MOV for safety, and there are 1 kilo ohm resistor to discharge this capacitor with excellent kindling, and there are two ceramic capacitors also connected, which is made a 50% ratio with grounding together just for safety reasons, and output also goes with same 200 kilo ohm 4 resistors phase neutral both for output sensing to the main processor unit. This time main processor unit is missing because it is this part is processing unit, which is very difficult to make or almost impossible to reverse engineer it at all. But I tell you, there are this processor is this is the main processor which is made. Let me remove the transformer out. There are clips, it's easily pull off. It's come out like that. So there's a clips. Let me open it. When you removing clip, keep in mind never overforce it, otherwise it's growth. It easily come off, and now it's come the main clip. There's a one clip. Now just remove this clip, we can push them. Let me hold it from like this. It will be lift and gently pull out the connector. Make sure never stretch the wires out and clip the item out like that. Now tell the main. This is a processor which is ST2F639T4M, which is the M Cortex processor. It is a 8-bit to 16-bit AVR microcontroller, 8-bit timer microcontroller, and this is a 74C5 number is this 595, which is a Smithy Tidal IC, and there is a 324A DC to 5 DC step down converter IC. So these feedbacks are sent in by these two converter IC, which is then step down, and then those two communicate with this microcontroller, and this microcontroller drive this shift register or Smithy Tidal IC, which can drive these two and plus this relay and plus this buzzer, and these are 16 metals. I think crystals. There is no written on this is a crystal oscillator, maybe 16 metals, and there is a TL431 voltage regulator. And there is one more IC which is a temperature IC. Number is 93LC46, which there is a temperature IC, and there is a buzzer, and there are some capacitors. There is a switches, and there is a 4 LEDs, and there is a couple of assembly capacitors. And this video is done with the next video very soon with their experiment with this transformer and further things. And this video is done with the next video very soon.